Thanks for watching my video today. We are going to discuss our property of definite integral. Okay, I'm going to discuss one by one and step by step. So our property 1 says that integral from a to b f of x dx is nothing but integral from a to b f of t dt, because our definite integral does not depend upon the variable. Okay, this x is the variable and t is the variable. Then is integration is independent of change of variable. If you change this x to t or so, the answer will be still the same. That means it is independent of variable. Okay, so we are going to prove here. Let capital F of x be the antiderivative, meaning if you differentiate f of no, if you integrate f of x, you get capital F of x. Okay, that's why we say that f of x is the antiderivative. That means the integral derivative of f of x. F of x. So then now let's do our left hand side. Then is integral from a to b f of x dx. So if you integrate this, you get f of x, and integration limit from a to b. So by our theorem of definite integral, okay, you plug this upper limit first, f of b minus f of a. Let's name this as equation 1. Now right hand side, it is integral from a to b f of t dt, which is capital F of t. If you plug the limit, so f of b minus f of a. So from 1 and 2, we have clearly from 1 and 2 is whether, even though here the variable are changed, but after we integrate this, we get the same result, meaning these two must be equal. Therefore integral from a to b f of x dx must be equal to integral from a to b f of t dt. If you have something like, if you have a cyclic, okay, let's say this point is a and this point is b. Cyclic is going like that. Let's say this mean integral from a to b. That mean integral from a to b. If you integrate, okay, let's consider this one, the better one, ab. If I integrate this one, that means our integral does not depend upon the path. Okay, this one, the path travel from a to b. But in case it depend only upon the initial point and the final position. Okay, initial point and final point only. It depend, or integral depend only these two, but it does not depend upon the path. Okay, so that's why we have this. So this proof our first property.